let's do IXL 7th grade AA.19. Go to Learning. Make sure you're on Math. Go to 7th grade. And then down to AA 13. 19. Area between two shapes. All right, so before we do that, let's go ahead and remind ourselves what the formulas for the areas of various shapes are. So on the reference pages, on page 12 is where we see area. So let's go down to page 12, which is right over here. And to find the area of a rectangle, it's just the length, or it's sometimes called the base, times the height. So you're just multiplying these two numbers. To find the area of a circle, it is pi times the radius squared. For a parallelogram, it's the length of the base times the perpendicular height, not the diagonal height, the perpendicular height. For a triangle, it is the length of the base times again, the perpendicular height, and then divided by 2. And for a trapezoid, it would be the sum of the bases. The bases of a trapezoid are defined to be the sides that are parallel to each other. So in this example, the side which is 9 units long is parallel to the side which is 3 units long. So these are the bases. So we would add up the two bases and then multiply by the perpendicular height, which in this case would be 4, and then divide all of that by 2 to get the area of the trapezoid. So please refer back to the reference pages as you are doing the IXL if you forget how to find the area of a shape. So going back to IXL, we want to find the area of this shaded region. That means the region that IXL shaded in green. Now, it's not hard to find the area of the whole triangle. In other words, if I wanted to find the area of all of this, well, that would be very easy. Just going back to the triangle formula, that's just length times height divided by 2. So if I wanted to find the area of everything there, then it would simply be 14 times 12 divided by 2. Okay, and that would give me 84 square yards. But that is not what we're trying to find here. We only want... Oh, that's from earlier what I was doing. All right, I don't know how to go forward, so now I have to erase this. Okay, we only want the area of this part, just this shaded region here. Okay, so how are we going to do that? Well, the strategy in this case is going to be to subtract. Actually, that what you just saw on the screen a minute ago was another example that I was doing. So here's our strategy. It's easier actually for me to explain this using Microsoft Word than IXL. So let me make this look sort of like the triangle that we have. Okay, looks sort of like it, right? So we have the big outer rectangle over here. A triangle. And we also have a smaller inner triangle over here. Right? So we have something which looks like this. And our job is to find not the area of the entire thing, just the area of this part over here. Now, the way that we can do that is actually very simple. If this, let's call that the big triangle. Now, what would happen if we took the area of the big triangle and subtracted the area of the small triangle? And we'll call this triangle the small triangle. What would happen? Well, if we were to do that, you can see, let me get rid of all that. If we were to subtract this, then what we would have left is just this shaded region over here. Okay, and then that's it. That's what we were trying to find. So that's our strategy to find the area of the shaded region. Just take the area of the big triangle or circle or square, whatever it is, and subtract the area of the smaller shape. Okay, so let's go ahead and do that. So the area of the big triangle is going to be 14 times 12 divided by 2. And the area of the small triangle is going to be 8 times 7 divided by 2. And we're going to be subtracting these things. Okay? Now, this is not too hard to do, but we'll just go step by step. All right? So this is going to give us 14 times 12 is going to give us 168. And that needs to be divided by 2. And 8 times 7 is going to give us 56. And that also needs to be divided by 2. 168 divided by 2 is going to be 84. And 56 divided by 2 is going to be 28. Okay, and then if we just do 84 minus 28, that's going to be 56. So our answer here is going to be 56 square yards. Okay, why is it squared here? Notice that all of these were yards. So for example, this was yards and this was yards. So if we do yards times yards, then we get square yards. So I would have square yards over here, and I would have square yards over here, and square yards minus square yards is still square yards. So we have 56 square yards. That's the answer for this one. Okay. Okay, next, both circles have the same center. What is the area of the shaded region? Again, we're going to find the area of the big circle and subtract the area of the small circle. So we'll write area of the big circle minus the area of the small circle. Okay, again, on the reference pages, you can see the formula for the area of a circle is pi r squared. Okay, pi times the radius squared. And usually it tells us to use 3.14. Yeah, here it is. So we're going to use 3.14 for pi. So that means for this one, we have to do pi times the big radius, I'm going to just call this r big for now, squared, minus pi times the small radius. So I'll call this r small, also squared. Now the small radius is just 5. So this is going to be pi times 5 squared. The big radius, you might think that the big radius is 9, but it's not. The big radius is going from the center all the way up to here. So that means that the big radius, remember, from here to here is 5, because this line is the same as this line. So the big radius is actually going to be 5 plus 9, which is 14. So we have pi times 14 squared. Okay? And we could actually go ahead and factor out the pi. No, actually, I don't want to. I'm afraid I might lose people if I start factoring, so let's just leave it this way. So we have pi times 14 squared. So 14 squared is going to give us 196. Remember, that's 14 times 14 is 196 times 3.14 for pi. So that's 615.44. So let's write that. Minus, again, pi is 3.14 times 5 times another 5. So that would be like times 25. So you could either say times 25, or you could just write it twice, times 5 times another 5. And that is equal to 78.5. So let's write that in. And then we'll just do 615.44 minus 78.5, which equals 536.94. And we're supposed to round to the nearest hundredth, but this only goes up to the hundredths place. So there's really nothing for us to do. So we'll just type that in. That was what, 536.94? Is that what it was? Yes. Okay. And that's it. Okay, so now we have two rectangles. So it's the same idea. It's just we take the area of, whoa. We take the area of the big rectangle and we subtract the area of the small rectangle. Now, to find the area of a rectangle, that's very easy. It's just the length times the height, or if you want to call it the base times the height, you can do that. So we're just multiplying these numbers to find the areas of both rectangles. So 13 times 15. Let's work that out. 15 times 13 would be 195. Ooh. Okay, minus 6 times 5 would be 30. I knew that one. 195 minus 30 is 165. So the rectangle examples, or the rectangle problems, are going to be probably the easiest problems to do. Okay, we have another rectangle problem. Actually, we have a square problem. But a square is just a special kind of rectangle. It's a rectangle where all the sides are the same. So it's the same idea. You would do 18 times 18, and you would do 12 times 12, and then you would subtract. Okay, so let's jump ahead to the next level. Okay, so this seems like it's, again, the same idea. Maybe I'll just explain how to round to the nearest hundredth, which I've done in a couple other videos so far if you've been watching all the videos, but I'll do it again in this one. So we want to do the area of the big triangle minus the area of the small triangle. Okay, remember, for a triangle, it's going to be the length times the height divided by 2. So, for the big triangle, it's going to be 25.6 times 33.6 divided by 2. And then minus, for the area of the small rectangle, is going to be 15.7 times 20.6 divided by 2. So let's do that. 25.6 times 33.6 equals divided by 2 equals 430.08. Minus 15.7 times 20.6 equals divided by 2 equals 161.71. Okay, so this problem is actually, yeah, I should have realized that. Yeah, I feel kind of silly now. I should have realized that from the beginning. This question does not require me to do any rounding. Okay, because if we do 430.08 minus 161.71, this only goes up to the hundredths place anyway. So IXL is telling you to round to the nearest hundredth, but there's nothing to do here because, again, the hundredths place is just 2 decimal places after the decimal point. So this is only going up to the hundredths place anyway. So I'll just show you where to look on Frydman Math on the reference pages if you do actually have to do some rounding. It's on page 1, and it's right over here. So step 1, locate the digit you're rounding to. That's the rounding digit. Step 2, locate the digit 1 space to the right. That's the decision digit. Step 3, if the decision digit is 0, 1, 2, 3, or 4, keep the rounding digit the same. If the decision digit is 5, 6, 7, 8, or 9, bump the rounding digit up by 1. And step 4, eliminate everything after the rounding digit. So, for example, if we were to round this number to the nearest 10, you could look up here. Oh, not up there. Up here. Yeah, that's better. Okay, you can look up here in the place value section if you don't remember where the tens place or the hundredths place or all those things are. The tens place would be 2 decimal places before the decimal point. It's a little bit hard to see, but that says tens right over there. Okay, so for this example, here's the tens place. So that would be our rounding digit. The next digit over is a 4. That's our decision digit. We use this digit to make the decision about what to do about the rounding digit. So since this is a 4, we're going to keep this the same. So the 7 stays a 7, and then we just eliminate everything after the 7. So that would be 870. In this example, since we're rounding to the nearest hundredth, this is the hundredths place right here, 2 decimal places after the decimal point. So that's what we would call the rounding digit. The decision digit is the next digit over. That's the 8. Now an 8 is going to tell us to bump this up by 1. So that rounding digit, which used to be a 2, we're going to bump that up to a 3. And then step 4 here is eliminate everything after that. So our approximation for this number would be 7.93. So there's a little bit of a review on rounding, even though I didn't actually have to round for this problem. So my answer was 268.37. Okay. All right, so this question is the same as the others. So I'm going to go ahead and jump a level. I'm at the challenge zone. What is the area of the shade? Okay, this looks exactly the same as the last ones. I'm going to do this problem, and if the next question is the same, then I'm just going to end the video there because it looks like the problems are repeating themselves. So again, this is a rectangle. So the area for rectangle is very simple. We're just going to multiply the length by the height. So the area of the big rectangle is going to be 81.5 times 87.7 minus the area of the small rectangle is going to be 51.9 times 45.7. Oops, clicked on the wrong thing. So I'm going to get 7,147.55 minus 2,371.83. Okay, and then let's subtract. Okay, and there's our answer. Again, we don't have to round this one to the nearest hundredth because it only goes up to the hundredths place. So there's nothing to round. So I'm not even sure why it asked us to do that. Maybe you have to round sometimes for some of them. I don't know. We haven't had any problems where we have to round. So that was 4,775 point, what was it? 72. Okay. All right. So this problem, it's maybe a little bit tricky, so I'll go over this one. It's the same idea again of taking the area of the big circle and subtracting the area of the small circle. The only twist for this one is you have to realize that this right over here, since the line is going all the way across, 58.2 kilometers would be the diameter, not the radius. Oh, and actually they're telling you that because they say D here. D usually is used to represent the diameter. So, but we don't want the diameter. We want the radius. Okay, so we want the distance from here to here, which is pretty simple. All we have to do is take 58.2 and divide it by 2, right? If we take the diameter and divide by 2, then we get the radius, and that would give us, what? We have 29 No. 20, no, I'm sorry. 24, 29, yeah, 29.1, right? 58.2 divided by 2, 29.1. Okay, so that would be the radius of this circle. That's the smaller circle, so I can go ahead and plug it into this formula right away. So remember, actually what I should say first is that to find the area of a circle, we need to do pi r squared. So for the big circle, it would be the big radius squared. And for the smaller circle, it would be the smaller radius squared. Now we just figured out the small radius here is 29.1. I've been making videos for hours now, so I'm going to use that as my excuse for getting confused with the 29.1 before. So anyway, I'm going to plug that in for the small radius here. Okay, now for the big radius, you might be tempted to just take this number over here, 21.3, and plug it in here, but that would not be correct. So remember, this is 29.1, and this is 21.3, right? So the radius from, let's use yellow. The radius from here all the way down to here would be 29.1 plus 21.3, which would give us 50.4. Okay, so that's what we're going to plug in for the big radius over here. And pi, so pi is 3.14. And then this plus this would be 50.4. Okay, oh, don't forget the exponent. So now let's go ahead and do 50.4 squared, so that means times another 50.4, times 3.14. So 7,000, 7,976.1024 minus, now we have 3.14 times 29.1 times another 29.1. And it's going to give us 2,658.9834. So now let's go ahead and subtract these two numbers. I hope I typed in everything correct. Oh. No, I did not. I did not. That was a 7, right? I hope that was a 7. Yeah, that's a 7. Okay, so I typed it in wrong. 7,976.1024 minus 2,658.9834 equals 5,317.119. Okay, I think I typed in everything correctly that time. Except remember, we have to round to the nearest hundredth. Okay? So that means that we're going to be rounding to this decimal place, which means we have to look at the next decimal place. And this 9 is going to bump the 1 up to a 2. So we're going to put a 2 over here instead of the 1. And that's... hope I didn't make any mistakes. Let's see. But I never make mistakes, right? So it must be right. Oh, okay. All right. And let's see. What is the area of the shaded region? Okay, it looks like this is the same as all the others. So I am going to end the video there. Hope that was helpful. Reach out if you have any questions, and have a great day.